Hello everyone, welcome back to Rakesh VALASA YouTube channel. First of all, thank you to each and everyone for supporting my YouTube channel. I am happy to share with you that recently I got one of the biggest achievements on YouTube, that is crossed 1 lakh hours. 1 lakh hours watching time in my YouTube channel. Uh, I got a good response for engineering drawing problems. Now also I am expecting the same response for the new course, that is engineering mechanics. Engineering mechanics. This course is also common to all branches. Especially this course is very important to mechanical and civil engineering students. Mechanical and civil engineering students. This course is very important for competitive exams like SSC, RRB, uh, DRDO, ISRO, BARC, NTPC, GENCO, GATE, etc. So don't neglect this course. This is the very important course, and you can got good score in the competitive exams. If you're watching my videos, my lectures first time, please do like and subscribe my channel. In this video lecture, I will deliver the following topics, that is definition of engineering mechanics. The second topic, classification of engineering mechanics. The third one is basic terminologies in engineering mechanics. Okay, once again, welcome back to engineering mechanics. I am Rakesh VALASA, assistant professor in Department of Mechanical Engineering. First of all, let us see the definition of mechanics. Mechanics is the branch of physical science that deals with the state of rest or the state of motion, is termed as the mechanics. Starting from the analysis of rigid bodies under gravitational force and simple applied forces, the mechanics has grown to the analysis of robotics, aircrafts, spacecrafts under dynamic forces, atmospheric forces, temperature forces, etc. Archimedes, Galileo, Sir Isaac Newton, and Einstein have contributed a lot to the development of mechanics. The mechanics developed by these researchers may be grouped as: first one, classical mechanics or Newtonian mechanics. These mechanics developed by Sir Isaac Newton. Isaac Newton. The second classification is relativistic mechanics. This mechanism developed by Albert Einstein. Albert Einstein. The third classification is quantum mechanics or wave mechanics. These mechanics developed by Schrödinger and Broglie. Coming to the definition of engineering mechanics. Engineering mechanics is a branch of applied science which deals with the laws and principles of mechanics, along with their applications to engineering problems. Engineering mechanics is very essential for an engineer in planning, designing, and construction of various types of structures and machines. Now, let us see the classification of engineering mechanics. Depending upon the body to which the mechanics is applied, the engineering mechanics is classified as two types. First one is mechanics of solids, second one mechanics of fluids. The solid mechanics is further classified as mechanics of rigid bodies and mechanics of deformable bodies. The body which will not deform, or the body in which deformation can be neglected in the analysis, the type of bodies are called rigid bodies. So in that mechanics of rigid bodies, there is no deformation, so delta x equal to 0. The mechanics of the rigid bodies dealing with the bodies at rest is termed as statics. The bodies are dealing with in motion is called dynamics. These dynamics again classified into two categories. The first one is kinematics, second one is kinetics. The dynamics dealing with the problems without referring to the forces causing the motion of the body is termed as kinematics. Here the kinematics referring to the forces causing the motion. Coming to the kinetics, it deals with the forces causing the motion, also called kinetics. Without considering forces, that is called kinematics. With considering the forces, called as kinetics. Coming to the mechanics of deformable bodies, if the internal stresses developed in a body are to be studied, the deformation of the body should be considered. This field of mechanics is called mechanics of deformable bodies or strength of materials. It is also called strength of materials. It is also called solid mechanics. This field may be further divided into theory of elasticity and theory of plasticity. Coming to the mechanics of fluids, liquids and gases deform continuously with application of very small shear forces. Such materials are called fluids. The mechanics dealing with the behavior of such materials is called fluid mechanics. This mechanics of fluids further classified into three categories. First one is mechanics of ideal fluid. Second one, mechanics of viscous fluid. Third one is mechanics of incompressible fluids. Okay, this is the brief discussion about classification of engineering mechanics. The next topic is basic terminologies in mechanics. See the first one, mass. The quantity of matter possessed by a body is called mass. The mass of a body will not change unless the body is damaged and the part of it is physically separated. When a body is taken out in a spacecraft, the mass will not change, but its weight Its weight may change due to change in gravitational force. Even the body may become weightless when the gravitational force vanishes but the mass remains the same. The second one is time. Time is the measure of succession of events. Succession of events. The successive event selected is the rotation of Earth about its own axis. Earth is rotated its own axis. This is called day, one day. To have convenient units for various activities, a day is divided into 24 hours. One day equal to 24 hours. An hour into 60 minutes. 1 hour equal to 60 minutes. Again this 1 minute equal to 60 seconds. Okay, this is regarding time. Coming to the third one, space. The geometric region in which study of bodies involved is called space. A point in the space may be referred with respect to a predetermined point by set of linear and angular measurements. For example, if we measure the point, let us take this point A with respect to the predetermined point. This point is called origin. These points are called coordinates. If the coordinate involve only in mutually perpendicular to the perpendicular distance, they are known as Cartesian coordinates. If coordinates involve angle and distance, it is termed as polar coordinates. Polar coordinates. The next one is length. It is a concept to measure linear distances. For example, uh, diameter of a cylinder. Here the diameter of cylinder is 300 millimeters. Here the millimeter is the unit of length. Uh, Take one more example. Height of a building may be 6 meters or 20 meters. Here the meter is the unit of length. However, depending upon the sizes involved, micro, milli or kilometers, these are the units are used for the measurement. Millimeters, centimeters, meters, kilometers. These are the units are used for measurements. Coming to the next one, displacement. Displacement is defined as the distance moved by a body or particle in the specified direction. For example, let us take xy plane. This is the uh, y, this is the x. Initially the point is A. This is moved from here to here. This is the B point. This point is moved from A to B. Its displacement in x direction, that is A dash B dash x direction, is A B dash. In y direction, that is B B dash. Okay, if a body moves from position A to B in xy plane, its displacement in x direction, that is a b dash, and its displacement in y direction, that is b dash b. Coming to the next one, that is velocity. The rate of change of displacement with respect to time is defined as velocity. That means velocity v equal to dx by dt. Units are meter per second. The next one, acceleration. Acceleration is the rate of change of velocity with respect to time. So A equal to acceleration, A equal to rate of change of velocity dv by dt. These units are, here v is the velocity, these units are meter per second square. Next one, momentum. The product of mass and velocity is called momentum. Momentum equal to mass into velocity. Here mass units are kg, velocity units are meter per second. You can also write Newton second, because Newton units are kg meter per second square. The next one, continuum. A body consists of several matters. Each particle can be subdivided into molecules, atoms, and electrons. It is not possible to solve any engineering problems by treating by a body as conglomeration of such discrete particles. The body is assumed to consist of a continuous distribution of matter. In other words, the body is treated as continuum. The next terminology, that is rigid body. This is very very important. A body is said to be rigid if the relative positions of any two particles in it do not change under the action of the forces. For example, I am taking one body, that is, this is the one object. Here I am taking same object after applying the forces. Initially the points are A, B, the initial position A, this is the B. After applying application of forces, the position changed in this way. Here I am applying the forces. This is the F1, F2, F3. You can see these two figures. This is the figure number A and this is the figure number B. In the figure number A, points A and B are the original position in a body. After application of a system of forces F1, F2, F3, the body takes the position in this manner. Here the new position is A dash B dash. A dash and B dash are the new position of a points A, B. If the body is treated as rigid, the relative position of A dash, B dash and AB are same. That means initially the points distance AB equal to, after application of forces, distance A dash, B dash. These are equal. That is, that type of body is called as rigid body. The last definition, particle. A particle may be defined as an object which has only mass and no size. This is very very important. The object which has only mass and no size, such a body cannot exist theoretically. However, in dealing with problems involving distances considerably larger compared to the size of the body may be treated as particle without sacrificing the accuracy. Let us see the few examples for particle. The first example is a bomber aeroplane is a particle for a gunner operating from the ground. Second example, a ship in mid-sea is a particle in the study of its relative motion from a control tower. The example 3, in the study of movement of the earth in celestial sphere, earth is treated as particle. Okay, this is the regarding about basic terminologies in mechanics. In the next lecture we will discussing about laws of mechanics. Thank you for watching. Please do like and subscribe my channel for more updates.